In this video, we are going to see the data set that we are going to use for our simple linear regression example using Python. So without taking too much time, let's jump right in. Imagine you are a human resource manager and you are curious about the relationship between years of experience and salary of employees in the company. So you suspect that when the years of experience increase, the salary also increase. The simple linear regression can help us quantify this relationship. So we have data for a group of employees. So this each row represent a single employee and showing their years of experience and salary. Now, wouldn't it be great if we could plot this data and summarize the overall trend between years of experience and salary? That's exactly what simple linear regression helps us achieve. So, in the next video, we will see how to pre-process this data set before creating our simple linear regression model. So, before creating any type of model, we have to initially do some steps like importing libraries, importing our dataset, separate features and dependent variable from the dataset, and handling missing values or any inconsistencies in the dataset, and split dataset into training and testing set. So in this example, you don't need to perform any data cleaning tasks like handling missing values or handling any inconsistencies. Here we have a proper data set. But if you want to learn more about these steps and data cleaning related things, you can watch my data pre-processing Python video. I will put the video link in the description. So in that video, I explain these steps in detail so you can learn more about these libraries and data pre-processing things. So now let's dive into our example. So in this first step, we have to import NumPy, Matplotlib, and Pandas library. We have given some alias like NP for NumPy, PLT for Matplotlib, Py, PyPlot, and PD for Pandas. So these alias we can use in future when we want to use some functions inside these libraries. Now let's run this section and import these libraries into the session. Okay, libraries imported successfully. Now we can import our data set, and also we can separate features and dependent variable into two variables like x and y here. Here, this x is the years of experience column, and this y is the salary column, because as our final objective, we want to predict salary based on the employee number of years of experience. Now, let's run this section and bring data into play. So after that, we can split our data set into training and testing set. Here we are splitting our data set into one third. That means we are taking 20 rows to training set and allocating 10 rows for testing set. Now let's run and split our data. So as a result of this splitting, we are getting four variables: xtrain, xtest, ytrain, and ytest here. So as said previously, you can learn these things in detail if you watch data pre-processing video. And that's all for data pre-processing. In this video, we will see how to build our first model. First of all, we have to import linear regression class from the linear model submodule within this Sklearn library. The linear regression class provides the functionality to create and train a linear regression model. This line creates an instance of the linear regression class by assigning it to the regressor variable. You are essentially creating a new object that can be used to fit and apply the linear regression model. This line is where the magic happens. This line calls the fit method on the previously created regressor object. The fit method is responsible for training the linear regression model. Here's what it does. This argument represents the training data for the independent variable. In simple linear regression, it's typically a 2D array where each row represents a sample and each column represents a feature, usually just one for simple linear regression. Each element in the array contains the value for that specific feature in that sample. For example, it could be an array where each row contains the years of experience of an single employee. This argument represents the training data for the dependent variable. It's typically a 1D array where each element represents the corresponding value of the dependent variable for the corresponding sample in the extrained data. In our example, it could be an array containing the salary for each employee. So by calling regressor.fit on arguments xtrain and ytrain, you are essentially providing the training data to the model. The model then uses this data to learn the relationship between the independent and dependent variables and calculates the parameters like slope and slope and intercept of the best fit line that minimizes the error between the predicted and actual values. So imagine you have a pile of data points representing years of experience and salary of employees. You created a new tool, like regressor here, that is capable of learning from examples. So by feeding it the training data, so according to our example, X train for years of experience and Y train for salary, so you are essentially letting the tool to discover the underlying relationship between these variables. So this allows it to make predictions about future salaries based on the new years of experience. That's how we can build our model. In this video, we will see how we can do some predictions using our trained model object. And also, we will do some visualizations to verify our model performance. So now our model object is ready here. Let's use this object and do some predictions as well as some visualizations. This line here, uh, ypred equals regressor.predict inside brackets xtest is where your simple linear regression model makes predictions on new data using the knowledge it gained from the training process here. So let's break this down. So this variable uh, represents the predicted values. So in this context, it will store the salary that the model predicts based on the unseen data points in X test. This predict this part calls the predict method on the regressor object. The predict method is responsible for generating predictions using the trained model. This X test, this argument represents the testing data for the independent variable. This follows the same format as extrain here explained previously. So here it's a 2D array containing the unseen years of experience values for which you want to predict salary. Essentially, this line takes the train model regressor and uses it to predict the dependent variable salary for the new data points X test that the model hasn't seen before. So imagine you have a friend and you train that friend on the relationship between years of experience and salary using past data, that means training data. Now you give your friend new data points representing the years of experience of employees they haven't met before, like testing data here. So this line ypred equals regressor dot predict is like asking your friend to predict the salaries for these new employees based on what they learn from the training data. So the predicted salaries are then stored in this ypred variable here. So this test should not have been used during the training process and this fitting process here. It's crucial to use unseen data for testing the model's generalization ability. So this predict method makes predictions based on the best fit line learned during this training process. The result ypred here, this array contains the predicted salaries for each data point in X test. So by analyzing the predicted salaries ypred and comparing them with actual salaries, we can evaluate the model's performance and assess how well it generalized to unseen data. Now let's run this section and move to the visualization part. So this code utilizes the matplotlib .pyplot library to create a scatter plot visualizing the relationship between years of experience and salary in our training data, along with the best fit line predicted by the linear regression model. First, we run this code and break down the code by looking at the output. Okay, here's the output. So this plt dot scatter, this line creates a scatter plot using the scatter function from plt. This extrain represents the data points for years of experience on x-axis, and this y-train represents the data points for salary on y-axis, and this red color, this sets the color of the data points in the scatter plot to red, like here. So this line essentially plots each data point in the training set as a red dot in this graph. So this helps visualize the actual distribution of the data points. So from the second line, this line creates a line plot using the plot function from matplotlib library. So this extrain, this argument is used here for consistency, although it's not technically required for plotting the line. This regressor dot predict. So this part calls the predict method on the train model regressor to generate the predictions for training data extrain. We call that the model learns from extrain and ytrain during the fitting process. Here we are asking the model to predict salaries based on the same experience values it was trained on extrain. So this blue sets the color of the line to blue. So this line essentially plots the best fit line in blue color. Uh, Here that the linear regression model learned based on the training data. The model calculates this line during the fitting process here, and it minimize the error between the predicted and actual salaries in the training data. And from this line, so this line sets the title for the plot, indicating that it visualizes salary versus experience for the training data here. And from this X label, so this line sets the label for X axis, years of experience here. And from this Y label, so this sets the label for Y axis, specifying that it represents salary here. So from this final line plt.show, so this line displays the generated plot on the screen. Overall, this code snippet creates a visual representation of two key aspects. So from these scatter plots, that means from these red dots, so it shows the actual data points from the training set, providing a sense of how experience and salary are distributed. And from this blue line, that means the best fit line, so it displays the blue line that the linear model learn based on the training data. So this line represents the model's prediction of salary for any given experience level within the training data range. So by analyzing this plot, you can gain insights into how well the model fits the training data. Ideally, the blue line should capture general trend of the red data points, indicating a good fit. However, if the blue line deviates significantly from the red dots, it might suggest that model needs further refinement or that a linear model relationship might not be best fit for the data set. So from this next code snippet, so this one is also very similar to the previous one, but it visualized the results on the testing data instead of the training data. So as previous, first of all, let's run this code snippet and break down the code. Okay, now you can see the visualization for test set here. So from this line, so this line creates a scatter plot similar to before, and this X test represents the data points for years of experience on the X axis, and but this time this is from the testing data. And this Y test, This represents the data points for salary on the y-axis, also from the testing data set. And color equals red means this keeps the color of the data points red. Here we plot the red dots for unseen data points in the testing set. So this helps visualize the actual relationship between experience and salary for data the model that hasn't encountered during training. So this PLT dot plot, this line remains unchanged as this previous line because it plots the previously generated blue color best fit line for reference. Recalls that this line was learned from the training data here. Uh, from this title line, this line changes the title to indicate that the new plot focus on testing data. Uh, then from the X label, this line and this Y label line remain the same, keeping the axis label consistent. And finally, from this show line, displays the final plot. So this code snippet visualizes the model's performance on unseen data, that means testing data set. So this blue color best fit line is same from the uh, training data visualization here, but here it's overlaid on the red dots representing the testing data. So by comparing the red dots, that means the actual test data dots, to the blue line, that means the model's prediction based on training data, we can assess how well the model generalizes to new data. Ideally, the red dots should be scattered reasonably close to the blue line. This suggests that model captured the underlying relationship between experience and salary and can make decent predictions for unseen data points. However, if the red dots deviate significantly deviate from the blue line, so it might indicate that the model doesn't generalize well, and further refinement or a different model type might be necessary. So in essence, this code snippet help us to evaluate the generalize, generalizability of the model trained on the X train and Y train. So it's crucial to use separate training and testing dataset to avoid overfitting the model uh, to the training data, which can lead to poor performance on unseen data. In this video, we will see how we can do a single prediction using the train model. So this line print uh, regressor.predict on 12. So it uses the train linear regression model regressor to predict the salary for a new data point with 12 years of experience. So this calls the predict method on the train model regressor. So this method is responsible for generating predictions using the learn model. This 12 here. So this is the argument passed to the predict method. It's a nested list containing a single value 12. This represents a new data point where we want to predict the salary. Notice that the value of the feature 12 years was input in a double pair of square brackets. That's because the predict method always expects 2D array as the format of its inputs, and putting 12 into a double pair of square brackets makes the input exactly a 2D array. So in simple terms, imagine you train your friend on the relationship between years of experience and salaries. Now you want to ask your friend to predict the salary for an employee with 12 years of experience, which the friend hasn't seen before. So this print statement, it's like essentially tells your friend to speak up and share the predicted salary. The requester.predict part is like asking your friend, what salary do you predict for this employee who had 12 years of experience? So let's run this code first. So you will see the predicted salary here printed in the console. So this number represents the predicted salary for someone with 12 years of experience based on the model we trained on our data. So some important points that you should remember is this 12. This format is crucial for providing the data in the expected format for the prediction with the Sklearn models. So the predicted salary is estimate based on the model's understand of the relationship between experience and salary learned from the training data. So it might not perfectly match the actual salary, but it provides an insight based on the model's knowledge. So from this section, so this line print uh, coefficient, slope coefficient, and this line print intercept of the linear regression equation. So uh, So from this line, in simple linear regression, there's typically only one coefficient because we are modeling the relationship between one independent variable and a dependent variable. So this line only print one coefficient slope. So this coefficient represents the slope of the best fit line that the model learned during training. And if the coefficient value positive, that indicates that the value of the independent variable increases, the predicted value of the dependent variable also increases. For example, if the coefficient is positive in a salary versus experience, so it suggests that the model predicts higher salaries with more years of experience. So for a negative coefficient indicates the opposite trend, for instance, in a model predicting house prices based on square footage, a negative coefficient would suggest the model predicts lower prices for houses with large areas, which might not be realistic but could be the case in specific data set. So this intercept. So this line prints the intercept of our linear regression model. So the intercept represents the y-axis value, where the best fit line intersects the y-axis. In other words, in the predicted value of the dependent variable when the independent variable value is 0. So the intercept might not have a real world interpretation in all cases. For an example, in a salary versus experience model, so it's unlikely that someone with 0 years of experience would have a positive salary. However, the intercept value can still be mathematically relevant for the model equation. So together, coefficient and intercept define the equation of the best fit line that the linear regression model uh, learned. So this equation allows you to uh, calculate the predicted value of the dependent variable for any given value of the independent variable within the range of your data. So let's run this section and see the output. So I have also created the equation here so you can understand the linear regression equation better. So that's all for simple linear regression example. Hope uh, you understood simple linear regression superbly. Next video, we will see how we can create multiple linear regression model for multiple features instead of considering a single feature. Until then, bye bye.